What if a bullet was struck by lightning midair? It's a 1 in a billion shot, maybe less. A bullet traveling at hundreds of meters per second intersects perfectly with a bolt of lightning. The air crackles, energy surges, but what actually happens to that tiny piece of metal caught in nature's raw power? Let's rewind just a fraction of a second. Someone, somewhere, fired a rifle. At almost the exact same instant, the conditions were perfect for a cloud-to-ground lightning strike. The stepped leader, an invisible tendril of charge, snaked its way down from the storm clouds, searching for a path to Earth. As it neared the ground, the electric field intensified, and a streamer of positive charge reached up from the ground to meet it. When they connected, the circuit was complete. The return stroke, the brilliant flash we see as lightning, surged upwards, carrying tens of thousands of amperes of current, heating the air in its narrow channel to temperatures hotter than the surface of the sun. And right in the middle of that newly formed intensely energetic plasma channel, our bullet. To understand the bullet's fate, we need to consider its construction and the nature of the lightning itself. A typical rifle bullet has a lead core encased in a copper jacket. Copper is an excellent conductor of electricity. Lightning, for all its power, will always seek the path of least resistance. So, as the lightning's return stroke erupts, much of that immense current will find a more convenient highway through the bullet's copper jacket than through the highly ionized but still resistive air channel. The question is, can the bullet handle it? We are talking about roughly 20,000 amps flowing through a very small object. The energy transfer would be significant. You might expect the bullet to vaporize instantly, a miniature explosion of superheated metal. But there's a crucial factor: time. A bullet is fast, it covers ground quickly. The lightning channel itself is only a few centimeters wide. This means the bullet will only be inside that intense electrical current for an incredibly brief period, perhaps a single millisecond, or even less. In that tiny window of time, can enough heat be transferred to melt or vaporize the bullet? Think of it like quickly passing your finger through a candle flame. You feel the heat, but you don't get burned because the exposure is too short. The bullet experiences something similar, just on a much more extreme scale. Calculations suggest that while the bullet would definitely heat up, it wouldn't absorb enough energy in that fraction of a second to melt completely. The surface might get scorched, perhaps some very superficial melting or pitting on the copper jacket, but the lead core would likely remain solid. It might warm up by a few degrees, maybe even tens of degrees, but not catastrophically. So, no dramatic mid-air disintegration. What about its path? Would the intense magnetic fields around the lightning bolt, or the forces from the current running through the bullet itself, send it careening off course? Again, the interaction is too brief. While there would certainly be electromagnetic forces at play, Lenz's law and Lorentz forces would make an appearance. Their effect over such a short duration on a fast-moving, relatively heavy object would likely be minimal. After passing through the lightning, our bullet, perhaps slightly singed and a tiny bit warmer, would continue on its trajectory. It would still be a projectile carrying most of its original kinetic energy. If it was aimed at a target, it would likely still hit that target with little deviation. The person or object on the receiving end would be none the wiser that their incoming projectile had just had a rather shocking experience. So what if lightning struck a bullet in midair? The answer, surprisingly, is not much. A flash, a surge of current, a momentary intense heating, but ultimately the bullet just keeps going. Another reminder that the universe can be both incredibly powerful and remarkably indifferent.